All right, howdy folks. So this is your practice problems video for angle relationships. So let's just go ahead and jump into it. All right, so we're going to start with just identifying some angle pairs here, and then we're going to use our knowledge of the angle pairs in order to write some equations and solve some problems. Okay, so let's take a look here. So number one says write all pairs of angle types in the figure below. Okay, so we just need to match up and figure out where the corresponding angles are, where the same side interior, exterior, alternate interior, and exterior angles are. Okay, so as a refresh, okay, corresponding angles are the ones that are in the same location in their groups of four. So like 1 and 6 are corresponding angles. So like angle 1 and angle 6. Right, so that's a pair. Another pair is 2 and 5. Another pair is 4 and 7. And then, I forgot my angle sign in front of 7. 4 and 7, and then 3 and 8. Okay, so in any set where you have two parallel lines cut by a transversal, so you have two of these groups of four, there's always going to be 4 pairs of corresponding angles. Okay, so there will always be 4 of these, and then there will always be 2 of all these other ones. Okay, so same side interior angles, remember, have to be on the same side of the transversal. So either both on this side or both on this side, okay, and they must be trapped inside the parallel lines, right? So my two sets of same side interior angles are 4 and 6, and then 3 and 5. Right? And then a similar idea for the same side exterior angles. Those have to be on the same side of the transversal. So either both on the left or both on the right, but they must both be outside the parallel lines. And remember, they have to be in different groups of 4. Okay, so that would be angle 1 and angle 7 would be one pair, and then angle 2 and angle 8 would be the other pair. Okay, and then we have similar ideas for the alternate interior and alternate exterior. Okay, erase some of my arrows here. Whoops, turn my pen back on here. Okay, so for the alternate interior angles, they both have to be inside the parallel lines. I'm going to change it back to this pink here. They both have to be inside of the parallel lines, so like here in this pink zone, but they also have to be on opposite sides of the transversal. So like 4 and 5 would be a pair. Here, angle 4 and angle 5. Right? And then angle 3 and angle 6 is the other set. Right? And then the last one here is alternate exterior. So again, obviously they have to be in the blue zone, okay, and they have to be in different groups of 4. One has to be on this side and the other has to be on this side. So we have angle 1 and angle 8. Please excuse my and symbols. They're not very easy to do with my mouse here. Okay, so angle 1 and angle 8 is in one pair, and then angle 2 and angle 7 is the other pair. Okay. All right, so give me a second. I have to erase my screen, and then I'm going to scroll down, and we're going to do a couple of problems where you actually have to solve for something using these angle relationships. All right, so I'll see you in just a second. All right, folks, so let's take a look at number 2 right here. Okay, so this is a common type of problem where they're going to give you one angle. Right? They give you exactly one angle in the figure, and then they're going to ask you to figure out the measures of all of the other angles in the figure. Okay, so I know that angle 1 is 145 degrees. Okay, so remember, if you watched the other video, we know that all of the obtuse angles in this picture all have the same measurement. Okay, and you can kind of see that from the angle relationships, right? If angle 1 is 145 degrees, then that means angle 6 also has to be 145 degrees because they're corresponding. They're in the same spot in their group of 4. Okay, and then if angle 1 is 145 degrees, angle 3 has to also be 145 degrees, right? Because they're vertical, right? They're these mirror image angles, so they have to be equal. And if angle 3 is 145, then angle 8 also has to be 145 because they are corresponding, right? So all of the obtuse angles, right? So the obtuse angles are all 145 degrees. Okay, and then it becomes a matter of, okay, so then how big are the acute angles? Okay, remember that you have a bunch of linear pairs right here, right? 7 and 8 have to add up to 180, right? Because they form a straight line. So to figure out what the acute angles are, right, we would do 180 minus 145, okay, which is 35. So 35 degrees. So all of the acute angles, 2, 4, 5, I really should have little degree symbols on these, 5 and 7 are all 35 degrees, okay? All right, so let's go ahead and take a look at number 3. So this is also a very common type of problem where they're going to give you some equations or some expressions for certain angles, and you have to use the angle relationships to figure out and solve for x. So really similar to what we did with the complementary angles and the supplementary angles and the vertical angles, right? Where you have to use the geometry rule to write an equation, like an equation that is true, and then go through and use your algebra skills to solve for x, okay? So let's go ahead and I'm going to help you set this up, and then I'm going to give you a chance to try to figure out, actually find x and then figure out how big angle 1 and angle 6 are, okay? So we have here that angle 1 is 3x plus 6, and angle 7 down here in the bottom right, is x plus 24. Okay, so the first question I want to ask myself is, what's the angle relationship? Right, what is it? Okay, so if I'm looking, these are on opposite sides of the transversal, okay, and they're both outside the parallel lines. Okay, so when you're going through and solving these problems, if you're trying to figure out what the angle relationship is, there's really 3 questions you should ask yourself. Okay, so you should ask yourself, okay, whoops, hold on. Here we go. Okay, ask yourself these 3 questions. Okay, are they vertical? So are they vertical or corresponding? Okay, so that's the first question that you ask yourself. Are they vertical or corresponding? Okay, if they are, then you know that they're congruent. If they're not, move on to the second question. The second question is, are they inside? Are they both inside? Or are they both outside the parallel lines? Okay, so that's the second question you ask. And then so if our answer for this one would be they're both outside the parallel lines. And then my third question is, are they on the same side of the transversal or opposite sides? My handwriting is getting smaller and smaller as I run out of space here. Okay, so same side or opposite sides. And these are on opposite sides. Okay, so since these are on opposite sides and they're both outside the parallel lines, that the angle relationship, like the angle relationship is these are alternate, that's your opposite, okay, that's the opposite sides, alternate, and they are both outside, so that's exterior, okay? So these are alternate exterior angles, which means they are congruent, okay? That's the rule. I get rid of this thing that says angle relationship because I'm running out of space here, okay? So the angle relationship is that they are alternate exterior angles, right? That is the rule. Okay, so then you're going to use that idea that these angles are congruent to write an equation. Okay, so remember, when things are congruent in math, we set them equal to each other. Okay, so I'm going to pause the video so that I can work this out. I would love for you to do the same. See if you can set up the equation and solve it for x. You should get a nice whole number when you solve for x. Okay, give it a try, see if you can find x, and then see if you can figure out how big angle 1 is by plugging x back in, and then how big angle 6 is by doing some subtraction. Right, so I will see you all back here after you have solved this problem. Right, see you in just a second. All right, y'all, so here we go. Here are your solutions. Okay, here are your solutions. Right, so the equation that you wanted to write was 3x plus 6 equals x plus 24, because these angles are congruent. So what that means for me when I'm solving an equation is that I need to set those two things equal to each other. Right, that is the rule. Okay, so I did minus 6 on both sides, and then minus x on both sides, so I could cancel these out, cancel. So you end up with 2x equals 18, divide that by 2, and you get your answer that x is equal to 9, okay? For part B, you had to take x and plug it back in, right? Plug 9 back into measure of angle 1, wherever you saw 9. So instead of 3x plus 6, it's 3 times 9 plus 6. So 3 times 9 is 27, plus 6 is 33. So that's your final answer for part B. All right. And then for part C, okay, for part C, I wanted to know the measure of angle 6, which is one of the obtuse angles, okay? So remember that these two angles have to add up to 180, right? Like the acute angle and the obtuse angles have to add up to 180, right? So even though there's no angle relationship between angle 1 and angle 6, right? Like they don't fit any of our angle relationships, but we can still figure out how big angle 6 is because we know that the two angles together, the acute and the obtuse, have to add up to 180. So I just did 180 minus 33 and got 147. So that's how big angle 6 is. All right. Okay, so give me just a second to clear my screen off, and then I'm going to walk you through a very short proof just to kind of get your mind in the proof arena, because in the next video we're going to do more with proofs, okay, and then we're going to do just a little bit more practice just with some angle identification and maybe solving another one of these where you have to solve for an x value. So I will see you in just a second to look at a couple more problems. All right, we are back, folks. So let's go ahead and take a look at this very short proof for our for some angle relationships. So here we have these two parallel lines that's given to us, and we're trying to prove that angle 1 is congruent to angle 7. Now, I know we already technically know this, right? We know this because of, like, it's a rule that I showed you, right? It's one of our angle relationships. Those are alternate exterior angles. So we already know, like, these are congruent. So this proof is trying to show you why they are congruent, like why that is a rule that always works, okay? So even though we know that these are alternate exterior, we're not going to use that as a reason in our proof today, right? We're basically trying to show why that rule is true here. Okay, so with any proof, you always start with what is given to you. And a great thing to do when you start writing a proof is if there's anything that they give you that's not already marked on the diagram, you should mark that information on the diagram. So we have that L and M are parallel. So what I'm going to do is I'm going to draw these little arrows. All right, I'm hoping you remember that from the notes video on the line so that I know that they are parallel. Okay. All right, so here I have my statements that I have to write. My first statement, remember, it's always exactly the same as the given statement. You just have to copy it exactly as it is. So line L is parallel to line M. That is given, okay? All right, their next statement here, let me erase some of my lines. Whoop. Their next statement here is that angle 1 is congruent to angle 5. Okay, so we have to ask ourselves, okay, what in the picture tells me that that's true? Like, how do I know that? Which angle relationship is it? So 1 is congruent to 5 because they are corresponding angles. Okay, so these are corresponding angles. Okay, so that's the angle relationship. That's why they are congruent. Okay, then step 3, right? And remember, this only works because the lines are parallel, right? If you remember from the notes video, if we had these lines that were not parallel, we wouldn't be able to use this reason. Okay, all right, then statement 3 says angle 5 is congruent to angle 7. Okay, so let me do some erasing here. Angle 5 is congruent to angle 7. So again, I want to ask myself, what's the angle relationship? How do I know that? Well, angle 5 and angle 7 are vertical angles, and we know that all vertical angles are congruent. Okay, so vertical angles would be your reason here. Okay, all right. Then my very last statement is going to match what's written by the proof statement. So angle 1 is congruent to angle 7. Okay, now one thing I want to make sure I mention in this video, because I cannot remember if I mentioned it in the proofs video, that this word right here, prove, is never, ever, ever, ever a reason. Don't put it in your reasons column. You're never going to use it as a reason. It's not a reason. Prove is not a reason. It's what you are trying to do, right? So you can't use it as a justification, okay? So remember, like I said, we know angle 1 and angle 7 are alternate exterior angles, but we're trying to show that that rule is true, okay? So we have to think, okay, how could I take my 2 statements here, right? Step 2 and step 3, how could I combine them to show that angle 1 is congruent to angle 7? Well, if you notice, they have something in common, right? Angle 5 shows up in both of those statements. Angle 1 is congruent to angle 5, which is congruent to angle 7. So you can write them in a chain, right? So remember, that's your middleman property, that you can cut out the guy in the middle and say that these two on the outside are equal, right? Or congruent to each other. So if we remember what that's called, that is the transitive property. Okay, that is the transitive property. Okay. Right, so that is a very short, very simple 2-column proof for some angle relationships, right? So remember, when you're doing proofs, you always want to ask yourself, okay, what else do I know? If I know the lines are parallel, what else do I know, right? And what else do I know that will help me, right? So there's a lot of angle relationships in this picture, right? But not all of them are, they're all true, but they're not all going to help me, right? Like if I had written something about angle 2 and angle 4, that's really not going to help me that much because they're they're not, like they're not really connected. Do you see what I'm saying? Like they're not connected to the proof statement at all. So you want to introduce statements or write steps that kind of bring in your key elements. Like I knew I needed to have a statement with angle 1 and a statement with angle 7 in it so that I could eventually combine them at the end. All right. All right, so I'm going to scroll here. So let's take a look at these last couple of problems in this video. Okay, so these problems here, 5, 6, 7, and 8, are giving you some statements, and you have to say whether or not those statements are true or false. Okay, and I told you that the lines are parallel, so I'm going to go ahead and mark them with my little parallel symbols. Okay. And so this is a good instance of where like the parallel lines look a little different because you're used to seeing them like this, right? Two parallel lines that are horizontal with the transversal kind of slashing through them. These parallel lines are vertical, right? So if we're looking at the same side of the transversal, that would be the angles on the top are on the same side, and then the angles on the bottom are on the same side, right? If we're looking for alternate sides, it would be like one angle at the top and one angle at the bottom. Okay, so for these questions, you have to figure out, I'm going to switch this back and actually type it a little bit. Okay, so for 5 through 8, we have to look at the relationship that they say on there and figure out if that statement matches with the angle relationship for those two angles. So I'm going to do an example for you here. So 5 says 2 is supplementary to 3. Okay, so if I look at 2 and 3, okay, and I want to ask myself, okay, ask myself the 3 questions. What's the angle relationship? So are they corresponding or vertical? The answer is no. Are they both inside or outside the parallel lines? They are both inside the parallel lines. And then are they on the same side or opposite sides? They are on the same side. So the angle relationship for number 5 is angle 2 and angle 3 are same side interior angles. Okay? Right? And then the rule is that same side interior angles are supplementary. Okay? So what that means is that so this statement is true. Right? You don't have to write everything out the same way that I did, right? You can do a lot of this thought process in your head about figuring out what the angle relationship is, right? And then figuring out what the rule is, and then figuring out if it's true or false, right? You can do a lot of that in your head. So I'm going to do one more. I'm going to do angles number 6 for you and kind of show you like how you would write this in simpler terms, okay? So it says angle 8 is congruent to angle 6. Okay, so we want to ask ourselves the 3 questions. First question, 1, are they corresponding or vertical? And they are corresponding. See how they're in the same location in their group of 4. Okay, and we know that corresponding angles are congruent. So this statement is true. So the way that you would write this is you would say true because corresponding angles are congruent. Okay, right, so that's a simpler way to write it. All right. So I'm going to give you all a couple of minutes here. I would love for you to try 7, 8, and 9 on your own. Okay. So some of these, so 7 and 8, some of them may be true, some of them may be false, right? Depending on the angle relationship, right? If the words that they use don't match with what you know the angle relationship to be, then those would be false statements. Okay. And then see if you can set up an equation and solve number 9, right? It's very similar to a problem that I did kind of in the middle of this video. I think it was number 3. So they gave us the measure of angle 2 and the measure of angle 3, which remember those are same side interior, so they're supplementary. So you would have to write an equation where they add up and equal to 180, right? So try 7, 8, and 9 on your own, and then check back with me here and see if you got the answers correct. All right, folks, so go ahead and check your answers for 7, 8, and 9, see how you did. So 7 said angle 7 and angle 3 were supplementary. That is false, okay? Let me do this so I can scroll, okay? Angle 7 and angle 3 are alternate interior angles, so those should be congruent, okay, not supplementary. So this statement is false because 7 and 3 are congruent. Alternate interior angles are congruent. And then for number 8, the angle relationship between 6 and 4 is that they are vertical angles. Okay, and they said up here that 6 is congruent to 4, which is true because all vertical angles are congruent. All right, and last one, number 9, we needed to figure out, they gave us measure of angle 2 and measure of angle 3, right? And they wanted us to figure out how big those angles are. So before I can do that, I have to figure out what x is, okay? And angle 2 and angle 3, if you look at the picture, are same side interior angles, right? So remember, same side means supplementary. So angle 2 plus angle 3 has to equal 180. So this is really similar to what you all have already done with supplementary angles, right? If we know things are supplementary, you add them together and set it equal to 180, right? So remember I told you when we first learned that term, supplementary, that would come back a lot, right? So here it comes up again, right? It pops up again. Okay, so we're using our geometry knowledge to write an equation, right? So angle 2 was 8x minus 20. So angle 2, 8x minus 20 plus angle 3, 5x plus 5 equals 180, right? I combined my like terms and got 13x minus 15 equals 180. I added 15 to both sides and divided by 13 to get x by itself, and I got x equals 15, right? And then remember, in all geometry problems, go back up to the question and see, did I answer the question? And here the question is not what is x, the question is what is the measure of angle 2 and what is the measure of angle 3, meaning I want to know how big those angles are. Okay, so in order to figure that out, I have to plug x back in to the two expressions that I have. So measure of angle 2 is 8 times, it's not 8x minus 20 now, it's 8 times 15 minus 20. Right? 8, 10, 15 is 120. Minus 20 is equal to 100. Okay? You could do the same thing for angle 3. Plug 15 in for x in 5x plus 5. Or you could say, well, I know they have to be supplementary, so I can subtract angle 2, which is 100, from 180, and you get that angle 3 is equal to 80 degrees. All right, y'all, so that is it for this practice problems video for angle relationships. In the next one, I'm going to do a couple of proofs for you for dealing with these angle relationships so we can see how those angle relationships can help us when we're writing proofs. So I will see you all in the next video. Bye, everyone.